Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 12.3 entitled Solving Radical Equations. And today we're going to solve radical equations. And to do that, we have to make sure that we get the radical by itself first, or we isolate it. That's our key vocabulary word there. And then next, we're going to square both sides, because remember, when you have a square root of something, the way that you get rid of that square root is you square it. So the square root and the squaring cancel each other out. And that's how you get the radicand to just kind of pop out. And then we've done equations like this before in chapter 9, but we just saw something like the square root of x equals, I don't know, 2. And then we would square both sides, and we would get the x by itself, and then we would just get the answer. And that's all we did. But today there's going to be more stuff inside the radicand than just the x. It could be a more complicated linear expression. It could be something like 3x minus 12 equals 4. And then we'd have to go through that equation solving process where we'd have to undo the addition or subtraction and then undo the multiplication or division. So here we'd have to add the 12 over and then divide by 3 to finish solving for x. So that's what makes the problems in this section a little bit more challenging than the ones we've done in the past. Now sometimes when you get your answer, it'll be a nice whole number, it'll be positive, but it's okay if you get a fractional answer or a decimal answer. And you can actually get a negative number as an answer. Now remember, you can't take the square root of a negative number, but you could put a negative number in here for x, and then when you simplify that side of the equation, it does actually equal the number that you have it set equal to. But if you're going to have a negative number inside the square root, that's when you get no solution. So no solution is when you have a negative number inside the square root. When you have the square root of a negative number. Let's just abbreviate it like that. Okay, so we have one example, but it has 5 parts to it that we'll work through. So we'll see 5 different types of these equations that you'll have to solve. And again, use these as a guide during your homework. Now part A, this is very similar to what we saw in chapter 9, where we just had the square root of x. So we want to, first step, isolate that radical. So I have to get the 7 over to the other side, so I have to add that over. So I'll have the square root of x equals 7 plus 0 is 7. And then to get rid of that square root, I have to square it. And what I do to one side, I have to do to the other. So then I get x equals 7 times 7 is 49. So that's kind of a refresher of what we saw in chapter 9. Very straightforward. And that's because there's just the x inside the square root. The x is the radicand. Now for example B here, we're going to have a little bit more to do because we don't have just an x as our radicand, we have 4x. But again, I have to isolate this whole radical first. This whole square root, I have to get it by itself. So here I have to subtract the 1 as my first step. Then I'll have the square root of 4x equals 4. And then I have to get rid of that square root. So I'm going to square both sides. Now when I do that, the 4 and the x pop out. Okay, the radical and the squared cancel each other out. So everything that was inside that square root, that radicand, that's what drops down. So 4 squared is 16. So now I have 4x equals 16. And now I can do that additional step of dividing by 4. So I get x equals 4. 16 divided by 4 is 4. So that's slightly different from what we've seen in the past. Here in example A, I just squared both sides and I got x. Now after I square both sides, I have a little bit more solving that I have to do. Okay, for part C, I'm going to get the radical by itself, and notice that this radical looks even bigger than the one in part B. Here I have 3x plus 1 as my radical. So to isolate that though, I have to add the 2 over to the other side first. So now I have the square root of 3x plus 1, and that will be equal to 8. Now I can't subtract the 1 and divide by 3 until I get rid of that square root. So I have to square both sides. Now remember, when you square square root, that radicand pops out. The 3x plus 1 is what pops out. And then 8 squared is 64. Then I'm going to subtract the 1. So now it's just like a linear equation that we've done way back in chapter 3. And then I divide by 3, and I'll get x equals 21. So for these first 3 examples, we've had nice, positive, whole number answers. So let's see what happens here for part D. Here I have my radical, the square root of x plus 2, but it's being multiplied by 4. So in the previous example, I had to undo some subtraction. Here, to isolate the radical, I have to undo this multiplication. So I'm going to divide by 4 on both sides, and then I'll have my radical isolated. So the square root of x plus 2 equals negative 5. Now, here's an issue. If I try to solve this problem, that means that whatever number I put inside this square root, I have to be able to take the square root of it and get a negative number for a solution. And that's not possible, okay? Because of that negative right there. I can't take the square root of some number and get a negative answer. So I can stop right here and just say that there's not going to be any solution. Now you could keep working through the problem if you wanted to. You could square both sides, so then you'd have x plus 2 equals 25, and then you would subtract the 2, and you'd get 23. But then if I put that 23 back in here to check my work, I would have 23 plus 2 is 25. So I'd have the square root of 25, but the square root of 25 is positive 5. 5 times 5 is 25, not a negative 5. Okay? So it doesn't actually end up giving me a true statement when I substitute back in. And part E, our last one, this is probably the most complicated just because it has a radical that's set equal to a variable. So this radical is already isolated though. That's nice. That's nice to see. So you might see some in your homework again where that radical is already isolated, but it might be set equal to a number, and then you just square both sides. Well, that's what we do here too. Even though I've got a variable over here on this side, I'm still going to start by squaring both sides. Since that radical is already by itself, I can square both sides. And then I'll get 4x plus 5 equals x squared. So now I'm going to have a quadratic. Anytime I have an x squared in my equation, that's going to be a quadratic that I have to solve. And in order to do that, I need all of my terms to be on the same side as the x squared. So I'm going to minus the 4x and minus the 5 over to the other side. So then I'll have 0 equals x squared minus 4x minus 5. Now this should look familiar to what we've done in the past. Okay, in chapter 10, we looked at trinomials, and this is a trinomial that we can factor. We can find the factors of 5 that add up to negative 4. So we're going to use guess and check. We're going to need an x and an x, because x times x is x squared. And then the factors of 5 that get me to 4, that's going to be 5 and 1. But I need them to get me to a negative 4. So I need the 5 to be negative and the 1 to be positive. And then I'm going to check. If I multiply them, they multiply to a negative 5. And if I add them, they add to a negative 4. So that's good. I did my factoring correctly. And then remember too from the last chapter, once it's factored, we set each of these little parentheses equal to 0, and then we can solve. So I'll finish the work up here. I'll have x minus 5 equals 0, and then x plus 1 equals 0. So here when I add the 5 over, I'm going to get x equals 5. And here when I subtract the 1 over, I'll get x equals negative 1. Now, really, anytime we should check our work for any of these problems, but we especially want to check our solutions when we have to factor. So if I take this 5 and substitute it back into the original equation, I'll have the square root of 4 times 5, which is 20, plus 5 equals 5. And the square root of 25 is indeed 5. So the left-hand side is going to match the right-hand side. So this is going to be one of my answers. If I try to do that with the negative 1, I'll have the square root of 4 times negative 1, so that's negative 4 plus 5 equals negative 1. And negative 4 plus 5 is 1. And then the square root of 1 is 1, but that does not equal negative 1. So that's not a true statement. So that means that this negative 1 is not a solution. So remember, when you're doing these types of problems here where you're factoring, you want to check your solutions. So check your answer, and you just have to do that by substituting them back into the original equation and seeing if you get a true statement. So anywhere there's an x, or whatever the variable is, you substitute that value back in for that variable. Okay, so again, have your notes out when you're doing your homework, when you're practicing these problems. Pay attention if you get stuck. Look in your notes for an example that's like the one that you're working on. Remember, you have to isolate the radical first, and then you square both sides, and then you just solve it like a linear equation. And the tough ones you might have to factor. If you get a quadratic, you might have to factor it. Okay? So if you get stuck and you have any questions, come on in and see me before school.